Especially since the launch of OpenAI's ChatGPT, the topic of artificial intelligence has entered the public consciousness and generated controversy. How powerful can we expect AI to become? Will it pose some kind of threat to human beings? If so, should research on AI be paused or even regulated by the government? These are some of the questions we will discuss on today's episode of New Ideal Live. Welcome to New Ideal Live, podcast of the Ayn Rand Institute. My name is Ben Bayer. I'm a fellow and the director of content at the Ayn Rand Institute. With me is my colleague, Mike Mazza, who's a associate fellow at ARI. And we're also very pleased to welcome to the show today Chad Mills. Dr. Mills has a PhD in computational linguistics from the University of Washington. He has extensive expertise and experience in applied machine learning and natural language processing, having worked at major tech firms like Microsoft, Facebook, Grammarly, and Twitter. So welcome, Chad.
Chad. Thank you. Happy to be here.
Chad, I think maybe we should start off just by getting to know you a little bit better, since some of our viewers might not know you. And I just rattled off a list of your qualifications. Maybe you could put a human face on that for us a bit and tell us what some of those areas of expertise involve, and how your experience gives you useful perspective, in particular on this question about AI that we're going to be discussing today.
Yeah, so just maybe for like the shortest bit of background there, like going into college, I really wanted to learn about robotics, end to end, everything, how computers work and how AI could be built on top of it from, like physics all the way up to AI. And it just so happened that as the time I was getting out of college and going to pursue a PhD, the subfield of AI called machine learning was really taken off. And I happened to find this great opportunity at Microsoft working on spam filters. So that was one of the first applications of machine learning. And so I kind of started my journey through industry and my post undergrad education in that field. And so I worked on a bunch of problems stopping all sorts of online abuse at Microsoft. I was working on newsfeed at Facebook, leading the data science team there for the newsfeed experience team. And really, when these language models started coming out, I know they've just gotten popular very recently. They've been getting better, and they've also been they've been more easy to use. I think that's really captured a lot of attention, but it was really clear maybe like 4 to 5 years ago that this was a really fundamentally new like area that there were going to be a lot of breakthroughs in. And that was actually a time when I stopped working at the big tech companies and moved to San Francisco from Seattle and joined the startup community and worked at Grammarly, one other NLP startup, just because it was a really exciting area and kind of at the center of the field of interest that I've been in for my whole career. But it was nice to have the opportunity to kind of specialize more from the general applying machine learning and AI techniques more broadly to this field of language where I was particularly fascinated. So that's really where my focus has been. I'm currently in the process of, exploring starting my own company in the space, and so it's just an area I've been focused on, kind of built my life around as a working professional, and so happy to share anything I can about it.
Maybe the best way to start our conversation then is to talk just about what is artificial intelligence, and if you think there is a contrast, how would you understand the contrast between how AI is understood popularly and then by people who actually work in the field?
Sure. So yeah, I guess the popular sense of it is probably the easier sense, which is, you look at any major movie about artificial intelligence or you read science fiction, and there's some big scary computer in the sky that's trying to take over the world. And I think that's like the general notion people have of what AI is. I think it makes for exciting plots and drama, especially, like if you want to see some technology like this that's very powerful, the kind of scary things people could imagine it could do tend to have taken over But yeah, as it gets closer, it is actually a real field where we do real things, and we're not trying to take over the world. So um, I would say artificial intelligence ultimately is a tool. So to think about it, it might be useful just to kind of contrast like what are tools for? What do we do with them? So I mean, we've had tools as humans, like as early as humanity, like even some of the early ancestors of humans had tools. So things like you sharpen a stick and you poke it through an animal so that you can eat it, because they don't like to be eaten until you do something like that. And tools enable us to do things like uh, they can either enable us to do something more efficiently that we can already do, or they can extend our capability of what we can do. So if you think of like cranes that can lift much larger things than a human possibly could, even a bunch of humans. And then when computers came around, there's this magical device that you take sand on a beach, kind of turn it into this computer. And when you arrange the silicone in this way, then it can do these amazing things where I think Steve Jobs described it as a tool for the mind. And so what it does is it kind of extends what the mind can do in some way. So if you think of like writing on paper versus writing in a word processor. So like when you make like first of all, it just looks nicer. It's easier to see what's going on. If you make a mistake, you don't have to rewrite everything after where your mistake was, or it doesn't look really bad because you were crossing out stuff and writing in margins. So it makes the process of writing much easier. And if you think about what computers do, it's a lot of stuff like that, where it's something you might be able to do in the physical world, but maybe not nearly as well or not at large of a scale. When you think about what the field of artificial intelligence has been doing, it kind of started out in the 60s and 70s with this grand vision to like reproduce what a human brain can do. But in reality, around like the late 90s, early aughts, what started happening as the field got traction and started being useful in the world was we started finding these narrow applications where you could take a simple decision that a human would make and find some way to get the right data into the computer with the right algorithm so that it could make that decision. So you take something that's very simple, but like it's simple to describe. Like for example, is this email spam or not? Theoretically, you could hire a massive army of humans to look at every single email coming through every mail server on the planet and say, is this mail spam or not? And then put it in the right folder, the inbox or the junk folder. But nobody would actually do that. That's not economical. But if we can produce a system, even if it's not perfect, where you're able to do that sort of classification automatically just by looking at the types of words in the email and stuff like that, then it turns out, like that's something that you can scale really well. So it started out as kind of making simple decisions and doing them at massive scale. So you could think of it in that sense as kind of like the default interpretation is you're replacing the mind for some task. But in reality, how it's really used is it typically takes a task that a human would be unlikely to do, because it would just be inefficient, and then it makes it possible to do that on a massive scale. That's not to say that there's no like taking the place of human jobs or something like that, but I will say that in the kind of typical case, it's something like that where you're taking something that happens at a small scale that's achievable, but doesn't make any sense to do at the scale you would need it to, and then automating that particular task. So anytime you're using speech recognition, that is coming through an AI system. If you're interacting with Alexa or Siri or Google's Assistant, that's AI happening behind that. I mentioned self-driving cars. There's also translation. So you go to a foreign country, you point your phone at a menu, and now you can read it in English and order something off the menu if you can find some way to pronounce the words in that language anyway. There's a recommendation system. So when you finish a show on Netflix and it recommends some other show for you, that's coming from AI. Certainly search. Search started out as just a directory of all the websites out there, but search is heavily based on machine learning and other AI technologies. You have computer players and video games. You have yeah, I mean, ChatGPT is certainly among the most impressive things. I think everyone is expecting that to be massively valuable. So I didn't give that answer because we haven't actually realized that value yet. But it's certainly a very promising direction. So it's certainly one that I'm heavily invested in myself personally. So I certainly view that as a big part of the future. So yeah, I mean, but there are even more behind the scenes things too. Like in agriculture, you use AI to spot where the parts of your land that are under nutrient, like there are less nutrients than you might expect, or something like that. So it's used everywhere. Like it's almost more challenging to look at something in the world and and say that this did not have AI at some part of its production process, or logistics for getting to you, or or whatever it is. Um, yeah, obviously there's interesting stuff happening now, and there's grander visions for it, but that is mostly what the field of AI is responsible for to date.
So, Chad, part of the reason we're having this conversation today is because of various proposals to regulate AI, which come up because of various doomsday scenarios that have become more popular in our culture, and we're going to talk about some of those later. But I thought it would be important not to give kind of primacy to the discussion of the negative, because one thing that often gets lost in these conversations is the positive. And you've touched on that a bit already by talking about some of the things that AI does for us that are really valuable, like spam filters. I wonder if you could expand on that, especially maybe by noting, what do you think is the most impressive thing that AI technology has done for human beings so far?
If I had to pick, I would probably say, I mean, there are so many things it does. It feels like it's kind of behind the scenes almost anywhere you look. Um, so it's hard to pick one. I mean, certainly there are applications like self-driving cars that just seem insanely good, but they're not widespread. So I wouldn't say that's like the biggest impact it's had so far. Something that's maybe like subtle and non-obvious would be like fraud detection. So think of how easy it is to pay people money nowadays through like apps and credit cards and things like that. It's very valuable for banks to make it easy to pay, because then you spend more money and those sorts of things. More money flows through their system, they get more money out of it. But that's really only possible because of the fraud detection mechanisms that AI enables behind the scenes that can stop that. You don't need physical money to kind of prove your ownership of something these days, and the risks are mitigable with AI technology. So yeah, I mean, there are a wide range of applications, but I would say a lot of behind the scenes stuff like that is where I find most of the impact.
What do you think of let's say over the next 10 years, are users, like ordinary users, going to be interacting with AI systems, um, and knowing it, not just in the background? How do you see things progressing in the short term, midterm?
So where is AI headed? What I would say is the general trend has been from you need someone who has a PhD in AI to do anything in AI, to making it much more accessible. So I think Google in particular was very good at hiring massive numbers of qualified people in AI. And that's part of how, I mean, their goal of organizing the world's information. That's how they were so successful at creating a wide range of really valuable products. Um, they were widely regarded as the biggest users of AI. And so what's happening though is it's becoming more ubiquitous. It's with something like ChatGPT, any person who can speak English. I don't know if they support other languages yet, but certainly English. You can interact with AI in some way. You can get it to try to answer your questions. Now, the things it can do are really remarkable, but I wouldn't say yet they're reliable. So the things AI tends to be best for today are the things that you're given a bunch of options and then you're able to pick, or you're able to validate. So it can propose something that you validate, or it can give you options to pick from. So when you think of like Netflix recommendations, they don't need to get the very first recommendation they give you to be the best one. As long as there's something interesting in the top five, it was useful. Google doesn't need to give you the very best answer to your question at the very top. If it gives you one of the top 10 being the right answer, that's pretty good and it's helpful. So I think maybe there's where the extra hype is in this technology is just believing that it's really doing something reminiscent of thinking, and kind of expecting it to be reliable, or thinking that just like some next step will get it to that level of reliability that approximates a human's thinking. At least that's my view of it. So what I would expect though at the same time is, I mentioned all these areas where AI is getting integrated. I would expect that in any business, you could potentially have AI solving essentially any problem where there's some repetitive task, where the tooling and the ways of doing this will get easier and easier. Um, I still think there's a big gulf between like robots interacting in the world and like having the intelligence that powers that, because there are um, so many weird things that can happen in the world that a computer doesn't know about, that it's hard to trust them in that. But I would say that just like I would expect AI to kind of continue its gradual penetration of essentially every field of human endeavor, to where, I mean, like, imagine AI assistants like just like helping you analyze what's going on in the world around you, personalized versions on your computer, just every repetitive process becoming a little easier at work. That's the sort of thing I imagine over the next 5 to 10 years. And, of course, we'll work and try to make it as good as possible. And, like things like ChatGPT, try to make them actually deliver on that promise. But I think it'll be a while before that happens, personally.
So you just mentioned a number of ways where you think this technology is going to, in effect, infiltrate so many different parts of our lives. That's perhaps part of what scares people about it, especially since it's called artificial intelligence, and that makes it sound like there's a living, thinking thing that's going to be in charge of so many areas of our life. So one thing we should definitely talk about is from your perspective, in what sense does it make sense to say that artificial intelligence really is intelligence? Uh, and maybe you have thoughts on what intelligence means in this connection.
Yeah, I mean, I think this is a really hard problem because uh, I don't think anyone has really found a way to measure intelligence in a repeatable way. So we have like intelligence tests, and you can train an AI system to answer questions on a test pretty well, because it's a pretty systematic set of patterns that computers are very good at recognizing. Computers are very good at pattern recognition. Um, so yeah, I mean, there are new benchmarks that people create with a wide range of challenging tasks. And then what you end up finding is that computers are able to solve them, but in ways that don't feel very intuitive. Is usually what happens. So we say, well, if a computer can do this, it's probably really intelligent. But then when we actually find a computer able to do that, when people build methods to do that with AI, what we tend to find is it relies on some like superficial patterns that don't feel very human-like, and it generally tends to be not as generally applicable as you would hope. With these language models, I think we're starting for the first time to see some broad applicability across a wide range of tasks, which is maybe what makes them so interesting and makes that promise something that people are really starting to invest in. But historically, it's been that an AI system only solves a narrow problem. And now that they're solving broader problems, they're like, as the technology develops, even where it looks really impressive and human-like, the people who are building them can generally see that they're not solving it anything like the same way as a human is solving it. And I think that the differences are also behind some of the reliability differences there. So, yeah, so I guess that's kind of how I think of like we don't really have an answer to how to measure intelligence. Anything we've tried, like you look at the Turing test, is like you interact with a computer through chat, and if it like if a human can't tell whether or not they're talking to a human or a computer, then it's kind of passed the test. But when you look at systems that actually have been most successful on Turing tests, like maybe fooled some portion of the judges, what tends to happen is they pretend to be like a 13-year-old kid who just learned English from the like Eastern Europe. They speak in like short, choppy sentences, and they're due to their age, they don't know as much about the world, and they tend to repeat a lot of things back and ask questions, and so you tend to find kind of like these little gimmicks that enable machines to pass tests that aren't necessarily reflective of what we actually mean by human intelligence. So what I think you can say is that human intelligence is very generally applicable. We feel, or we're able to learn about the world. We have like actual knowledge that we can rely and depend on. We can explain our thought process, how we came to an answer. What computers are capable of is, finding some patterns in input data. So if you say, when I see a bunch of email messages, this is a spam one, this is a spam one, this is not, this is not. You give it a bunch of examples. It can find patterns in the words and say, okay, like this one looks like it's not a spam message because the words kind of follow some pattern that you can't typically explain what's going on inside, at least the modern models. You just have kind of like a bunch of math and statistics that kind of output a black box answer. And so there's not really this notion of something that you can see and inspect inside the model that looks to us anything like human knowledge. And I don't think any test yet proposed to kind of make this a scientific question rather than kind of just an evaluative judgment call. I don't think we're there yet.
Yeah, so Chad, you talked a few times about um, whether or not certain AI programs can generalize to other tasks beyond something very narrow. And is that the same thing as what's I've read in the press called artificial general intelligence, that you could have some AI system that is able to take on any arbitrary uh, um, decision or task a human might do, or is there some other meaning?
Yeah, I think that's the basic distinction. And like historically, back in the 60s and 70s, that's what you kind of wanted to do in AI was create something that roughly mimicked what a human can do when they're thinking with their brain and consciousness. And it kind of became taboo to talk about that because that whole effort failed in the 60s and 70s. And there was this AI winter, it's called, where kind of interest and development in AI was much lower. And then when it started coming back, when some of these like techniques that had been developed combined with much more powerful computers and things like that started solving these narrow tasks. Anything that sounded like those grand visions from the 60s and 70s was just kind of like, no, no, we're doing like real useful stuff here. Don't like, please don't pollute what we're doing with that. We want to like, we want to do things that we can rely on and that are actually going to work. And what's happening now is you're starting to see signs that some of these methods with massive scales of data and supercomputers bigger than anything imagined at the time, um, they can now do things where they can solve several different problems with essentially the same training process. So the machine can kind of learn something that applies to multiple problems. Um, so I think that's part of why we're starting to hear people talking seriously about artificial general intelligence. I think
Mm.
it's actually a good thing. It's a healthy thing that we're kind of seeing that, okay, we've kind of really got nailed down this problem of solving individual narrow problems. Now we want to work towards solving broader problems. Now, at this point in time, it's still relatively narrow. I mean, um, you don't. I think when we have robots in the world that we're giving instructions to and they're going and carrying out the instructions, I think then you can say like, how is this really like how general is this intelligence? How do we compare that to a human? What is it good at and bad at compared to a human? Right now, like when you're typing text into a box or the sorts of things that AI is currently capable of. It's still hard, but we're kind of on that pathway of getting there. And I will also just note that I think Lex Friedman in particular was very valuable in getting people talking in this direction as well. I think he was teaching at MIT, and I don't know if he had a course on this, but certainly that's where I started hearing this word come up a lot more. But he kind of like made it so that it wasn't quite as taboo. He like brought famous people in, interviewed them about it, got them thinking big, and so that's kind of the trajectory we've been on. And I still think we're quite a ways away from it, but that's the basic idea: is yeah, more general problem solving and something more resembling what a human mind can do.
Let me ask a follow-up about that, because in addition to having the expertise that you have in uh, computational linguistics and artificial intelligence, Chad, you've also studied a fair amount of philosophy. So I'm curious if you could say more about what you see as the difference, the fundamental difference between even what the best artificial intelligence can do, and what human intelligence involves and
Yes.
means.
Sure. So the first thing is the way we use words in this space is a little fuzzy. So if you think of what a human is doing in terms of our intelligence, we have this conscious mind, we're thinking, we have this introspective capability, we can explain what we're doing. And when you have a computer, there's no thought process going on. What it is you've kind of done some statistics on inputs and outputs, but there's no cognition. So we have an awareness of the world around us. We're integrating, we're forming knowledge on that. And what they're doing is kind of having a computer guide the inputs and outputs and trying to get it to kind of replicate some pattern matching thing. So that's what computers are doing in essence. Um, so when I think of actual intelligence, I think of like something like what humans are doing. And since computers aren't aware in any sense like that, it just feels like something fundamentally different, like a tool, not like a mind. So the way we use words, though, is like the computer made this decision, or something like that. We use words kind of like what humans are doing as analogies to what computers are doing. And I think it's just important to keep that distinction in mind. It would be very awkward to say every time you talk about a computer taking some action, a computer did something resembling what a human would call a decision or something like that. So as a shorthand, we use these metaphors, but it's useful to keep in mind that the process going on in a computer is a deterministic kind of programmed thing using statistics to find patterns. And what we're doing is grasping the world around us, integrating that into knowledge, and making reliable decisions that we can explain and iterate and improve on.
So then, a lot of the worries about AI we read about in the press are packaged together with worries about, well, if we create a computer system that mimics human intelligence, it'll start to have um, goals and plans at odds with human beings, and that's dangerous. This sort of Skynet type worry. But it seems to me that there are other worries one might have about the technology that are disconnected from any um, assumption that we're going to create artificial minds. So, do you think there are? What's your take on the space of legitimate and illegitimate worries about the danger of the technology?
So when I think of like what are the worries I have, I don't personally have any worries that there's like some intelligence out there in a computer that's like secretly scheming and plotting behind me. I think the sorts of problems that practitioners have is like, why does this model keep thinking my cat is a dog? Or um, like, how come when the email has a bunch of images in it, like we keep thinking those ones are spam, even when they're just like advertisements? Like these are the sorts of problems practitioners have when they're looking at machine learning models and trying to figure out, well, like what sorts of things is the model leaning on? How is it coming up with this particular pattern as the one that it's learning? And so, yeah, these like grand scheming sort of notions don't really have much to do with it. If you think of like things that are legitimate worries, I would say they're things like, how do you feed in data that's representative of the problem you want to solve? So, for example, I think whenever you see a face recognition problem, and you just look at the composition of the teams that built it, they tend to have different races and genders and things like that. The distribution tends to be very different than the population of users. And so if you just kind of build systems and train them on data of the people making the system, then it tends to, for example, it's very common when face recognition systems get built that it does less well on people of darker skin color than lighter skin color. And there are like statistical patterns like that. And that's really bad, both because you want your system to be effective in all cases, and also because it looks really bad for the companies, like they're actually racist or doing something inappropriate, even when their goal is just like build a facial recognition system that works. You have to get data that represents the problem you're trying to solve. And I think those are problems that are both technical and like have political and ethical judgments that are made on top of them, whether like accurately reflecting the intentions of the people doing those things or not. And so I would say like in this field, that's actually what I would consider the biggest challenge is, just making sure the models work right and that they're making fair and reasonable, um, or they're finding patterns that are reasonable and kind of approximate, in some sense, what humans are doing without. Um, I guess most of these models tend to be statistical and they take in a lot of factors into account. And you want to make sure that it's not leaning on factors that are really irrelevant, because it's very easy to find patterns in any noise in data. And so, yeah, just making it representative. I would say that's the biggest one I'm concerned about.
One class of concerns I've heard that unrelated from is this going to turn into something like Skynet, just as that their how they get from the input and outputs is obscure enough that if you hook them up maybe to something dangerous, that they'll start uh, they'll do something unpredictable and undesirable. Like if you hook them up to a banking system or weapons or some dangerous industrial process, that just all of a sudden it'll do something that you couldn't have anticipated. And um, is that just as science fiction as Skynet, or is there some reason to have that kind of concern?
Yeah, I mean, I would say that that's a real concern. And that is something that any practitioner would need to be like very well aware of. So I think the way you should think about this is there's someone rolling dice in any artificial intelligence system today. Like it's finding patterns. It's using like typically when you start with like the main technology used today is called an artificial neural network. There's a bunch of kind of numbers that are computed and used to find patterns from the input data to the output data, and you could think of it as like typically those are initialized with like random numbers, and then you try to improve on that. And if you give it a different set of starting random numbers, you'll end up with a different model. So there are truly like random numbers inside these models. And so I think the goal of anyone building these systems is to build something that's, right a lot and wrong a little. I don't think anyone building these systems expects them to be wrong never. That's just one aspect of the challenging nature of the problems that we're solving with this field, is that if there were a deterministic, easy way to do it, humans would just program that in. And we're solving really challenging problems. The world is complicated. The types of examples you see have a wide range. There's borderline cases. There's mistakes that you can make. I mean, humans make mistakes too. So you can never expect an AI system to be perfect. So if you're hooking, nuclear weapons up to an AI system, I would say that's a bad idea. I wouldn't say that's a flaw in the model. I would say that's a flaw in the person who made that connection. But in either case, like, there's certainly like a risk to be aware of. But yeah, I would say that you just have to understand what is the nature of these models, what are they good for and bad for, and use them in the right places. So it's not something that keeps me up at night, but I guess I also trust the people that have been like in charge of that button for a long time are careful about what they hook it up to, and I'm kind of trusting they don't like. There are a bunch of things they don't do, including hooking it up to random number generators.
You emphasized toward the beginning of our conversation that you think of AI as a tool, and that implies that tools can be used well, they can be used poorly. And so, yes, we should probably have a policy of not hooking our AI up to nuclear weapons, but that's a policy we can enforce only if we're the good guys. When I think as just an amateur about what could be the worst possible consequences of AI, I think about what happens when malevolent actors start using them, and you can already see uh, early versions of this if you look at uh, the bots that populate social media with fake accounts and the way they spread computer viruses. With that kind of worry in mind, and you should comment on whether or not you really think it is a worry, what are the kinds of things that good actors can do to safeguard against the use of AI especially by bad actors?
Yeah, I mean, I would say whenever there's a tool, there's going to be good actors and bad actors, like people using that tool for good things and bad things. There's always some sort of cat and mouse game involved there. So, yeah, I was at Microsoft for maybe like 12 years or something, mostly working on how to stop various forms of abuse. And we would have an algorithm, and let's take a spam filter because I've used that a few times. Um, the bad guys, what they would do is they would figure out through reverse engineering roughly how the spam filter works. They would send like here's an example of how you could do that. You could take a message that is clearly legitimate and send it, and it gets through. You start adding words that are probably pretty spammy to it, and like just one at a time. You send an email with just that new word added, then just one more word until it gets caught. Now you start sending more messages so you have this like slightly bad message. Now you like send another message with a random word in it. And if it doesn't get caught that time, then what you added was a good word. So you can like reverse engineer this and figure out what are all the things they think are good and bad words, and and then they use that to craft messages where they'll put a bunch of really obviously bad stuff next, and they'll just fill it with a bunch of good stuff kind of hidden at the bottom that nobody looks at, and use it to get past the system. So they can use AI, they can reverse engineer AI, they can, this problem is as old as the technology itself. And I would just say that fortunately, the way these systems work, there are clear regularities and patterns they have in the way they operate. These models tend to be a little more brittle than you might expect. So for example, if you take an image recognition system, you give it a picture that looks like a dog, and it'll say dog, and then you like put some noise in the image. Like you just change a handful of pixels to like slightly different colors and things like that. Now it might suddenly think it's a horse, even though to any human it still looks exactly like a dog. Like these things are trained in ways that tend to be like they tend to reproduce, like when you give it a bunch of input data, it tends to reproduce that pattern, but the mistakes it makes are very different. So when bad guys start using these models, you can typically find statistical patterns in the way they're interacting with you, such that if they do this at scale, you can detect that. Now, if you find an individual person trying to attack some particular individual target, like some high value government official or something like that, those typically require like different sorts of approaches. You're not going to find the same statistical patterns. You're going to have intelligence about who's doing it and like police work type stuff. So, I mean, I think it's a complicated thing. I don't think AI is fundamentally different. I mean, like when airplanes came around, then criminals could transfer goods much faster across wider distances, and that created a set of challenges. And just like if you look at the history of technological development, you'll find that the bad guys can also use that technology. And so yeah, like fortunately, this particular tool tends to be one where you can detect patterns, at least at scale, when it's misused. I mean, even in like marginal cases, like where some student is using AI to write their papers for a class, you can still put that text into a system that can tell you, was this what's the probability this was generated by GPT or Chat GPT, and a teacher can use that as a tool to evaluate that. So there are solutions to these things, but I don't think it's fundamental to AI. I think it's fundamental to the problem of like malicious actors and the way they use technology. And you just have to have a set of tools and the same technology and try to stay ahead of it. And that's challenging, but it's manageable.
So, Chad, something I hear a lot about is the idea that once we have human-designed AI systems powerful enough, we'll be able to set them to the tasks of self-improvement, and we'll have some sort of vicious or virtuous cycle, depending on how you think about the value of these things, where it reaches, sometimes it's called like a intelligence singularity. This is the premise of Nick Bostrom's book about superintelligence, that that there'll be this explosion and we'll get the create itself to be the most intelligent possible. Is there any plausibility to this outcome?
Yeah, so I think this idea has been around for a while. I think part of the reason why it's gaining some traction is there's like a particular line of reasoning that has some plausibility to it. So maybe I'll just kind of share that and then kind of how I think about that. But um, so back, I've talked a little bit about kind of the ancient days of AI back in the 60s and 70s, and someone got the idea a long time ago of like, what if we kind of represent what the brain does, and maybe we can get computers to think like people do. And it's been a long arc of development. That early work kind of failed, and there were some problems with the early approaches. But throughout the challenging periods, there were always people working on that problem of how do we kind of represent the brain in a computer, kind of detached from thinking, just like how do we simulate what's happening in a brain. And what's interesting is through this early phase of AI taking off and really having impact across all these areas of our lives, like we talked about, it was predominantly other approaches that were dominant. And it just in the neural kind of model approaches, they tended to be a little behind. They were slower, a little bit harder to get to use. Like maybe a year or two after some new development was kind of out, then the neural network people would say, hey, we can do this with neural networks too. It was just kind of, I would say, lagging. But there were people who are firmly convicted that, hey, if you kind of model what a brain does, that's how we actually need to get to intelligence. So the effort kind of continued. And what happened relatively recently, like somewhere around, within like the last 10 years at least, was the scale of data we had to work on got much bigger. The power of computers got much bigger. And it just so happened that out of all the techniques that people were using, this approach that kind of roughly mimicked how a neuron in the brain works and kind of scaled that up, it just so happened that scaled better to larger data and compute than any of the other methods we were using. So you used to be able to fit as much data as you could on a computer. Maybe you take like 1,000,000 records to train your spam filter, and that can all fit on one computer. But when you take every piece of text that's ever been written or something like that, much larger sets of data, much larger databases of computers. Neural networks have this, or the artificial neural networks, the kind of brain modeling approach, has this cool property where you can have layers and layers and layers of these models on top of each other, and they work together nicely. And it just there's a particular algorithm called backpropagation where you take the error at the final output and kind of propagate the errors back all the way through it and kind of update all your numbers along the way. And basically, it makes it so that it can take advantage of larger data sets better than the other approaches could. So now pretty much everything in the field everything in the field of AI is built using these neural models. And the basic building block of that is something that very roughly approximates a neuron in the brain, very roughly. And then when you compose them together, there's some more approximation. So it's not actually doing what the brain is doing, it's just kind of a rough attempt at modeling it. And so I think the proponents of this idea that there's a singularity, they look at it and say, wow, if you just add more data and you add more compute, it seems to be getting better and better and better. And so if we just keep adding more data and we keep adding more compute, then it's eventually going to reach super intelligence. I think that's the basic argument that most people with this belief in the field kind of follow, because they've actually seen these kind of artificial neural network approaches getting better and better with more data and more compute. This treats the problem of intelligence as essentially a problem of, kind of neurons connected together, and that leads to intelligence. I think the reality is, if you look at the types of problems that AI has been solving, especially since these neural network approaches became more prominent, you see that they're mostly things that kind of the analog in a human is done by low-level functioning in the brain, which is probably not too surprising. But you think of things like perception. So these models, what made them so prominent and what really showed people that these models could be so effective was a giant leap forward in recognizing, like, what is the category of an entity in an image? Like, is this a dog, or is this a cat, or is this a horse? That was where they made the big jump. They're really helping in speech recognition. So essentially taking in censored data in some messy form and kind of converting that into something computer interpretable. And those are where it's made most of the gains. And now language is kind of the next thing that's really interesting. It doesn't quite fit that model yet, but it's also not at the same level of reliability. So I think there's some plausibility to this whole line of reasoning, in the sense that we're saying, there's this arc of development. You give something more data, you give something more compute, and it'll just keep getting more intelligent. But there's no recognition for the fact that the arc that it's been on is essentially something akin to a subconscious integrating sensor data, and not to a conceptual level understanding of the world. Or, like, I think we're at step 0 of that. We don't really have anything like that in a computer. And so I think there's some equivocation and kind of reductionism happening in this idea. And so the hope is that this arc will continue. And then maybe an interesting way to evaluate this on a more practical level rather than just philosophical is that you look at what a human can do is, like, if they hear a word a few times in context, they can start kind of figuring out what it means. Right now, these language models are reading essentially every text ever published by humans that's currently still available. Basically the whole internet, Wikipedia, books that have been published in the past, things like that. And it still has major problems in its ability to reliably answer simple questions, or it makes up citations and does all these other sorts of things. So there's still a fundamental difference, and it's not like we can just invent 100,000 times more data, because this is all the data that humans have ever produced. So there's all sorts of practical problems in addition to the philosophical problems. I certainly expect the methods will get better. We'll see improvements, but I think there's a difference of kind that is kind of being papered over as a difference in degree, personally.
So, Chad, a big part of the reason we want to talk about this topic today is, as I mentioned at the top, it's entered the public consciousness, and to the point where now the worries that people have about AI, which we'll talk more about later, have led certain prominent entrepreneurs to and thinkers to talk about pausing research on AI, maybe even under the force of government regulation. So I wanted to put up on screen here a passage from an open letter that was recently released by the Future of Life Institute. It's called Pause Giant AI Experiments, an open letter. It was co-signed by people like Elon Musk, Yuval Hariri, Steve Wozniak, Andrew Yang, many others. And here's what they said. Here's the essence of what they said. They said AI systems with human competitive intelligence can pose profound risks to society and humanity, as shown by extensive research and acknowledged by top AI labs. Advanced AI could represent a profound change in the history of life on Earth and should be planned for and managed with commensurate care and resources. Therefore, we call on all AI labs to immediately pause for at least 6 months the training of AI systems more powerful than GPT-4. This pause should be public and verifiable and include all key actors. If such pause cannot be enacted quickly, governments should step in and institute a moratorium. So, Chad, I'm very interested, especially as someone who's worked for many years in this field and who is now an entrepreneur in this field. What are your reactions to it, and what kind of implications do you think it would have for your work and for the industry in general?
Yeah, this is the most interesting thing happening in what I regard as the most interesting and developing field right now. And certainly, I think pausing efforts is just going to pause human progress. I don't I mean, in some sense, the way that it's worded and written, like there's a small number of actors publishing or building and publishing models of that sort of scale. So, in some sense, many people's jobs in the industry, including mine, would presumably just keep going on, but we wouldn't have as good of tools to work with. And, like they're it's not like they're just saying everyone working in software with anything having to do with AI needs to stop. I mean, this would affect OpenAI and Facebook and Google and a handful of companies like that directly. I think it's the indirect effects that would be the worst. Aside from the fact that if you think about it, these places, like look at OpenAI, they've hired a bunch of really smart people that are so motivated to go and solve these problems. I was at Microsoft and the after effects of some of the antitrust there that stopped some of the development. I remember at some point, if I remember correctly, this is roughly how I understood it. It wasn't my part of Microsoft, but like Office paused development for like a year to write documentation so that other people could use or have access to something that Microsoft was doing. And like all the smart people working, I mean, I'm overstating it, but like there was a large brain drain out of that area of development and towards other parts of the company, other companies. I think that this sort of regulation and approach will be, it won't just be like pausing development for 6 months. It'll put like a serious uh, blockage, I guess, in the development in this area. I mean, it'll also push it to other areas. Like certainly, there's a lot of people thinking of applications of the existing models, and it's not that all work on AI will stop, but I certainly think if you think of how many areas of your life AI is touching and making better, I mean, we talked about like in agriculture, it helps the food you eat, it helps you get the goods you get from Amazon or wherever else. It helps with pretty much everything. And so, the world is slowly getting better. And pausing on this, I think, would be, pausing on reaching our future potential.
It's really interesting that you point out how pause, or especially a regulation on this industry, could have the brain drain effect that you mentioned, because it would almost be a kind of ironic form of punishment if people are worried so much that the artificial intelligence is going to take over, and they're worried about the dangerous threat that it poses to human beings. But the consequence of their worry is that actual human intelligence becomes inhibited and unable to learn more about the world and about the about the products of the mind. That's really concerning. I mean, surely there have been many other new technologies in the past that people were worried about, where if we had restricted them in the same way, the development of them, we wouldn't have the standard of living that we have today. So it's kind of amusing that restricting artificial intelligence also has the effect of inhibiting the freedom of the actual human mind. And that's ultimately what we're talking about here.
Yeah, and
And we
I also
have,
just want to add one, sorry, I just want to add one little bit to that, which is there's also this notion in that statement about it being public and verifiable. Um, that's also something where, like, when I talk about a Microsoft writing documentation and like having meetings with external regulators and all these sorts of things, like that's the sort of thing that slows you down and makes you hate your job. So it's not like, even if they didn't pause it, if they just did that like public and verifiable thing of like how you're developing it or something like that, like the nature of these regulations is such that it definitely has that sort of effect to different degrees depending on how strongly they're implemented. But yeah, it's more than just a pause even.
And making it public and verifiable, I mean, depending on what they mean about that, it seems like it would have the effect of uh, making it impossible for companies who've invested millions of dollars in new technology to maintain trade secrecy, which is important
Certainly.
for maintaining a competitive advantage in a for-profit industry.
Yeah, that's certainly a concern too. I mean, I don't know the mechanisms they might use to enforce that, but yeah, that would be a big problem.
so you raised the counterfactual. Imagine if certain revolutionary technologies had been paused or slowed. We don't really need the counter. I mean, think of the promise that nuclear power had to people in the 60s and 50s, when all the uses of atomic energy that were projected, and none of that materialized in very large part because of a de facto moratorium on the development of that technology. So we have missed out on potentially world-changing technology because of irrational fears about the dangers.
That's a good example, though. I suppose the comeback would be, yeah, but if you want a real example of a new technology where you let the genie out of the bottle and it alters the course of history in a negative way, they might also cite nuclear weapons
Mhm.
as yeah, you can put up safeguards, you can try to keep it. Only the good governments will have it, but the technology proliferates to bad regimes, and then we're trapped in a arms race and Cold War. Um,
That's true, but
although
that wasn't the rationale for restricting nuclear energy.
that's true,
That it'll be weaponized. Yeah,
and I
it was
mean it is.
weaponized first.
Yeah, and I mean it is important to have safeguards against proliferation, I think. So that's, and nobody's denying that that's a threat. But that goes back to what Chad was saying about how you have to use AI in smart ways to guard against malevolent AI users. So I don't think there's any way out of that. But we should spend some time still talking about uh, and I don't want to spend too much time on it because I find it maddening to do so. Some of the doomsday scenarios that are written about and talked uh, about AI, and you've seen a lot of them championed lately by a figure named Eliezer Yudkowsky. He's the head of the Less Wrong blog. He shares a lot of ideas with the Oxford philosopher Nick Bostrom. We all read Bostrom's book, Superintelligence, to get ready for this conversation today. And it's it's hard for me, at least, to know how seriously even to take their proposals, uh, or to know how serious they are even being. And I'll just mention some of the things that they say. and I'd be curious to hear your reaction, Chad. I have some reactions I want to share too. But so we have, for example, the idea that we discussed already, that if you get a sufficiently intelligent artificial general intelligence, what they call a super intelligent machine, that you would have something that could more or less work to achieve any arbitrary goal that it's been given, but that even if we assign it to pursue and achieve a goal that would be conducive to our welfare, like the genies in the folk tales, they would find perverse ways of implementing the goal. So if we ask it to make us all smile, maybe the AI will make us all have permanently frozen smiles that we can't stop. Or if we ask it to make paper clips, that it'll just devote all of its time to and all of the resources in the universe to piling up paper clips, and this will eventually lead to human extinction. And there are then these kind of fantastical stories told about how we wouldn't be able to guard against any of this, no matter how much we know, and no matter how many safeguards we take, because, well, the artificial general intelligence will be so intelligent that it will know how to make sure we don't know that it's coming. It will cover up all its tracks. It will pretend to be malfunctioning. It will manipulate users into helping it out and helping it to get out of the computer into the world somehow, and use nanotechnology to create. It's really pretty fantastical. So I have some thoughts on this, but Chad, I'd be curious to hear your reaction, especially as someone who's very experienced in this field.
Yeah, so I mean, first of all, the like pictures painted of a universe full of paper clips instead of humans and stuff like that seems rather fantastical. I think there is one thing that's kind of like a real concern that is legitimate there, I think, which is like these models, they tend like today they're very good at solving very narrow problems. And when you build a model, it tends to be for a narrow application, and you don't want it to do stuff too far outside of that. Like you don't want your chess playing robot to play poker or something like that. Like it'll just do a horrible job at that. So the further removed the system is in operating on things different than what it was trained on, the worse it's going to do. So in that sort of sense, it's more like hooking a model up to the nuclear launch than than the issue of like the model making crazy mistakes like this. I mean, we don't have any examples of systems like this that just go well beyond, because the systems are designed to operate within the sphere in which their decisions are effective and have been demonstrated to be effective and that sort of thing. So getting to the place where we have an AI that is actually capable of going out in the world and executing instructions and stuff like that, we're far from that. I would assume, an early step to that would be maybe you have like a mining robot that goes and chips away at rock in a cave somewhere, and you start seeing its ability to find the right path to go down, and like how it goes about kind of collecting the minerals, and then slowly it starts doing a wider range of tasks related to that. So I think the process of rolling out an AI matched with robotics, I mean, right now there are fixed robotics in car factories that like stay in one place and have like a single arm that does certain tasks. So I think the process of rolling out any new technology is a process of understanding the scope in which you can trust it and the scope in which it can act. And so this is kind of taking a bunch of steps away and just say, well, let's just imagine we have an algorithm that we think is generally intelligent, and so we're just going to throw it out in the world and let it do whatever it wants. And that I don't think that represents how technology actually develops or how it's actually used in the world. But there is some relevance there, that the further away from what you're training it to do, the more mistakes it will make.
I'll share with you my reactions to this. There's three. One is that if you really had some kind of artificially intelligent computer that we literally could not control, one thing that means is we can't just turn it off. And when it starts posing problems, the idea that we couldn't just turn it off presupposes that we've somehow now also solved all of the world's energy problems. I mean, we can't even keep the power on all the time in California and in Texas, like the headquarters of the tech economies. And so somehow the machines will have had to figure out a way to create a completely perfect, reliable, uninterruptible source of energy. Now, maybe it's because these mining robots will figure out how to get the uranium to get the nuclear energy that we otherwise haven't wanted to use. I don't know, but if we've solved so many problems that we now have solved all the world's energy problems, and now we have to worry about the uninterrupted supply of energy that would power the computers, that would be a pretty good problem to have, is part of the way I think of it. But then the other two are methodological observations about the way a lot of these stories get told. And I have been calling them stories on purpose because it's not obvious to me that there's real evidence of these possibilities. One of the things that we emphasize in objectivism in Ayn Rand's philosophy and her epistemology is that not just anything that you can imagine is a real cognitively processable possibility, that you have to have specific evidence to say that something might happen. And very often it really is just on the level of, you can imagine this computer being so smart that it could do all these things. And so to me, a lot of these arguments resemble the same kind of arguments that you get for things like Cartesian skepticism. Like, how do you know that you aren't really the victim of an evil demon who's used all of his powers to deceive you, and you think you're sitting at a chair in front of the fire, but really you're just a victim of the demon and part of his mind? And Mike, it's probably not a coincidence here that someone like Bostrom, who makes these arguments about AI, is also an advocate of that simulation theory, which says maybe we already are all just in the dream of some supercomputer somewhere. And so
Yeah.
it's
One of the
incredibly hard.
there's a kind of a form of obscuring what you're doing that's common to it's I think it's telling that Bostrom is also not just connected to that simulation argument. Isn't he part of the effective altruist long-termist
Yes, indeed.
crowd? And Yudkowsky is adjacent to them, and it's this sort of argument or pseudo argument that says, like, well, if you can see that there's a greater than zero probability that so and so will happen, and then you run the numbers from that, and it gives the appearance of it's a scientific, there's numbers and equations, and you're talking about probabilities. But if you keep in mind the point you were just making, that, well, possibilities need evidence in their favor in order to be possibilities, then that comes out to just be a blatant misuse of those tools of thinking about uncertainty. This is a kind of obscure, like a mathematical obscurantism. I don't exactly know how to describe it, where you're using pseudo sophisticated tools to cover up the fact that you're just spinning out fantasies.
Yeah, and that point about probability that you just mentioned leads to my other point about their methodology. Yeah, so they will often say, okay, you might think it's unlikely that we'll get this evil supercomputer that destroys the world, but all that matters is that there be some small finite amount of probability. If the impact of that computer coming into existence is sufficiently bad, and they would take the extinction of the human race as the worst thing you could imagine, well, you multiply the admittedly tiny probability times the extremely negative expected disutility, and they say, well, that's still a very high expected disutility. It's not as high as the actual the 100% probability, but it's still very high, and that's why you should then worry about it, and that's why you need to have a pause and maybe regulations on the kind of precautionary principle. But the way I see that argument working is it's a kind of reverse form of Pascal's wager. If you're familiar with Pascal is the French mystic who says, yeah, there's a small chance that God exists, but if he does, and if you believe in him, you'll have an infinite reward of happiness in the afterlife. And if you don't believe in him, you'll miss out on that. And to me, it seems
You'll
like
have an infinite. You have an infinite disutility in hell.
yeah. So it's the motivation by fear version of Pascal's wager, in effect, and has the same problem, namely that when you're talking about the possibility of something which you can't give any definitive identity to, because by hypothesis it's something you can't understand. You're either a mortal human and you can't understand the infinite God, or you're a mortal human and you can't understand the super intelligent uh, computer. Then how can you even think about it and make these kinds of probability assessments about it? I mean, so Pascal's argument works if you assume you know that believing in him will yield this infinite reward. But how do you know that that same God doesn't want you to be an atheist and will punish you if you believe in him? And there's no way of parsing out all these different possibilities and deciding which one is more possible than the other. And I think the same works for the super intelligent computer. How do we know that if we don't develop it, we're gonna miss out on a super intelligence that's going to magically give everyone infinite orgasm? I mean, it's just, how do you weigh that completely non-cognitive possibility against the, I think, equally non-cognitive possibility of these uh, these dooms scenarios? And so
There's a
I've
there's
tried very hard to grapple with their arguments, and the more I do it, the more it seems like there's no there's no definite proposal based on definite evidence that you can actually assess.
Yeah, I mean, certainly, in order to have a probability, you have to have observed something, and in many cases, these arguments are kind of relying on things that are far outside and far from our range of observation. I personally think even the idea that we'll have the singularity, where we'll have this super intelligent um, computer, is arbitrary. And so anything after that, where you're trying to imagine how it's going to act or anything like that, I think that is you're already in the realm of speculation and not of like science or real reasoning. So yeah, I think there are multiple levels on which you can make that argument.
I'm curious how widespread these sort of fantasist worries are amongst AI researchers, because I certainly get the impression, reading about this in the popular press, that it is widespread. But I've also read from particular AI researchers who claim that the kind of Yudkowsky, this is so dangerous, we need to blow up Russian server farm kind of paranoia is really an outlier. So, what's your impression of how actual researchers are thinking about the different risks and scenarios?
I mean, I think there's a mix. I would say there's generally like a common framework for thinking about intelligence that many people in the field have, where they think, just recreating some physical action of neurons without consciousness, without anything like that, could lead to intelligence. I think that is a pretty widespread common belief. Like, there is no free will, reductionism kind of approaches. Uh, so I think that's common. I think the like extreme fear, like actually being worried about it to those sorts of degrees, is abnormal, like quite abnormal. Um, but I think many people, because of those views of how, like, of what intelligence is, how the mind works, consciousness being an epiphenomenon, those sorts of things, I think they tend to give some more plausibility and credence, and they don't speak out against the crazy things as much as they would if they had a better handle on like what intelligence is. And so I think it lets them spread easier. It lets you find researchers who support things, and like many opportunities where researchers aren't saying anything against them. But that's how I think it works.
I think we've actually covered most of the ground that we wanted to cover today. So before we start to wrap up, was there anything else, Chad, that you wanted to share with our audience on this topic?
No, I mean, I think everyone is right to think this is an exciting space. And, assuming we can get past things like this letter, I'm excited to see where the field will lead, and certainly hope to be part of that. So, yeah, I'm glad everyone's interested and excited about it as well.
Great. Well, thanks very much for helping us to better grapple with this very timely topic. I think we'll start to wrap up and share some announcements. First one about next week's show. Next week on New Ideal, we will be discussing the topic of the divine right of stagnation. This will be a conversation between my colleagues Ilan Giorno and Nikos Sotirakopoulos on the topic of an essay that appears in Ayn Rand's book, The Virtue of Selfishness. That'll be next Friday. We'd also like to remind you that if you enjoyed this podcast, please consider subscribing to it on YouTube. Click that bell button to get notifications for when we go live or when we post new recordings. If you're watching the recording right now, please consider leaving a comment or liking it or sharing it. This helps the Google AI to optimize the algorithm in our favor, and that's the kind of AI we like very much. So please help it do its job with your human intelligent decisions. Same thing happens on Facebook. So if you're watching there, please consider doing the same thing. And finally, if you have questions or comments about today's episode, or if you have other topics you'd like to suggest, please email those to newideal@aynrand.org. We read all the emails that come in. We try to answer as many of them as possible. I recently completed a batch of answers to your questions, and sometimes we will occasionally do episodes on the topics that you suggest. So thanks very much for sending us those. Otherwise, again, I want to say thank you to Chad Mills for joining us today. Thank you, Chad.
Thanks, Chad.
Thanks for having me here. Thanks, guys.